this is what I have as my final solution. So I have x1 bar is equal to x2, x2 bar is equal to x3, x3 bar is equal to x4, and finally x4 bar is equal to minus 3x3 plus sine t x2 minus 8x1 plus t squared. 1, 2, 3, 4. It was a fourth order differential equation. I've converted it into first order, a system of first order differential equations. And as you can see, I have 4 of them. So you can write that down. Okay, I'll repeat it. Now, guys, you're given this first order differential equation and you want to write it with respect to new variables. We already know that x1 is y and x2. This is what we've been using all along, our new variables. But now since we are having up to the fourth order, we will need 4 new functions. So that's why I've started from here. x1 bar is y bar, x2 bar is y double prime, x3 bar is y third prime, x4 bar is y fourth prime. That is if we start generally from here. We knew that x1 is y bar, so x2 is y prime. What we were doing. So I've started from this point, this second one here. Now, what is x2 prime? X2 prime will obviously be x3. Now, x3 bar is y third prime, which is our x4. And x4 prime is y to power 4, which we've made now the subject of the formula. By taking all these values to the other side of the equation, then we can be able to express our y raised to power 4, as we've done here. Now, we know what our y double prime is. Our y double prime is x3. Our y prime is x2, we replace there, and our y is x1, we replace. The t squared is just standing there on its own, so we are not replacing it in any way. So having to write all this in terms of our new variables, x1 and x2, then we'll have our x1 prime being this. This is a differential equation. As you can see, this is prime, x2 prime, x3, x3 prime gives us x4, and finally, x4 prime will give us this. So we have this system here with these 4 first order differential equations. Now, the next thing which is very important for us to know is how exactly we can go about solving this systems of differential equations. So we want to look at how exactly to go about solving them. Okay. Okay. So let's look at how to go about now solving them, or rather, how to first of all write them as matrix equations. That's not very hard, so probably I'll just do 1 or 2 examples, then we can go about how to solve them. Now, how to solve them when we've already written them in matrix as matrix equations shouldn't be hard, because you guys have already done eigenvalues, eigenvectors, so you know how to go about that, and also how to go about solving homogeneous and non-homogeneous equations. You've also looked at that previously. So, number 5. This example number 5, actually we've done this example. So let's look at this example. And now what we want to do is to convert it into a matrix equation. Converting it into a matrix equation. So you're given, let's say, a second order differential equation. You're being told to, first of all, break it down into a system of differential equations. And then after doing that, you convert it into a matrix equation. Now let's look at this. This is a simple example. I don't know if you've done it before. Minus 6y prime plus 4y is equal to 0. So solution, let's say, let x1 be equal to y, let x2 be equal to y prime. Now differentiating, what are we getting? Differentiating, we get x1 prime is equal to y prime, and then x2, so is equal to y prime, which is equal to x2 eventually. We are done with that. And then x2 prime is equal to y double prime. Make y double prime the subject of the formula here. We're going to have 6y prime minus 4y. Okay, now that is done. So the next thing, let's write this system of differential equations. We have x1 prime is equal to x2, and then we have the other one, x2 prime is equal to minus 6y prime. What is y prime? X2. So we have not minus 6 really, but positive 6 x2, and then minus 4y. And what is y? X1. So this is our system, which we need to convert into a matrix equation. So the matrix equation becomes, basically, this is, we write this as a column vector. I can write it as x prime bar. Let me write it in a better way. Prime, and then this is equal to, now this right here, I can write this as a matrix with, let me just write it here so that you can see it clearly. The position here, let me have this as 0, x1, and then I have x2. Then here I have minus 4, x1, and then I have 6, x2. So taking the coefficients, here I'll have 0, 1, minus 4, and then I have 6. Multiplied by x, this x here, which basically stands for x1, x2. Clearly, the x prime bar stands for x1 bar and x2 bar. And the x bar stands for x1, x2. And clearly, if we open this up with all this, then we get whatever we have back. So this is the matrix equation of this particular system. And for all the systems that we've already done, we can actually be able to express them in their matrix form, or we can express them as matrix equations. So maybe I can do for like 2 more. Just write that down. I don't think that this should not be hard. Write it down, and then now we can look at how exactly to go about solving them. Have you guys written this down so that I rub or open a new page? Let me know in the comments. Done. Okay. Okay, so let's have this as our number 2. Let's write it in the matrix form. Let's have 3. Okay, so first of all, convert to a system of first order ODEs. And then after doing that, write the matrix equation. Write the matrix equation. Let's do that very fast, and then you confirm our answers. Now, for this particular question, look at the conditions that we've been given up there. Look at those conditions. We've been told So we've been told that y of 3 is equal to 6 and y prime of 3 is equal to -1. Now, in order for us to rewrite this system, we came up with new variables. We said let x1 be equal to y, x2 be equal to y prime. So when we are converting this system into new variables, that is x2 and x1, then also the boundary conditions will be converted. So if x1 is equal to y, meaning y of 3 is x1 of 3. From this conversion, y of 3 is x1 of 3, which is 6. And x2 is equal to y prime, meaning y prime of 3 is x2 of 3, and it is equal to -1. This is directly from replacing the variables, is what we get. I hope we are together on that. Let's do one last example on this one, then we look at how exactly to go about solving them. Okay, next example. I don't know which example number it is, so let me just assume it's that. So y double prime plus 5y minus 2. So this is y prime is equal to sine t, given that y of 0 is equal to 4 and y prime of 0 is equal to 12. Now, rewrite into a system of first order differential equations. Rewrite this into a system of first order differential equations. And hence, write the matrix equation. Can you guys do this we have like about now, we have a lot of time to go. Convert also the boundary conditions. Are you working on it? You're quiet, so let me know in the chat if you're working on it. Yes, Ruth, you've raised your hand. Just a minute. Yes, working on it. Okay, yes, yes, yes. Okay, I see. Ruth, you've raised your hand. You can talk. John, you're going to say let x1 be equal to y, let x2 be equal to y prime. Then differentiating, we will have x1 prime is equal to y prime, x2 prime is equal to y double prime. Making double prime the subject of the formula, we will have minus 5y prime plus 2y plus sine t. Now, having this, we can be able to write this as x1 prime. This is equal to y bar, which is equal to x2. This is our first system. And then the second one is x2 prime is equal to minus 5. Instead of y1, y prime, we will have x2 plus 2. Instead of y, we will have x1 plus sine t. This is our second. And these are our conditions. I'm waiting for it to load properly. Okay, guys, I think it's back on now. Sorry about that. So I hope we are together because I want to wrap this and still do this on this same page. Because the next thing I want is to convert it into a matrix. Now, I don't know. I think I'm just going to wrap the question. I'm just going to wrap the question so that I can be able to do it on the same space. So wrapping this question here, what we want is now to write the matrix form of the system that we've gotten. We want to write the matrix form. And I want you guys to see how I'm going to do it. Now writing the matrix form. So let me just use a different pen. This is the system. This is the system. This is the system. This is the system. So if we come here, these two values here, let's have them as x prime bar is equal to, now here x1 is not there, so we'll have the value of 0, then the coefficient for x2 is 1. Then here the coefficient for x1 is 2. The coefficient for x2 is -5. Close that bracket, and then we have our x bar. Now notice we still have something left out that we have not accounted for, which is our plus sign t, which is basically standing on its own. So this is what we have. This is what we have in this particular case. It's a little bit different because of this here. I hope you guys see how exactly we go about. Don't forget the sign t. The sign t is just standing on its own, so we write it here on the side. I hope we are okay. Where x1 bar is equal to x bar x2 bar, and x bar is equal to x1 x2. Now we have less than 1 minute. We log back in, and now let's look at how to go about solving. We look at how to go about solving these questions. I hope we are together up until that point. So you can write in the comment section. Let me know if we are together up until that point. When we come back, we do something